Hey guys, just a quick video to go over the beginning of chapter 6, which is about polynomials and adding and subtracting functions. It's important in this chapter that you really understand and study vocabulary. So let's go through a few of these. A term can be a constant, a variable, or the multiplication of both, constant and variable. So the examples are listed in the middle of your screen right here. A monomial is a constant, a variable, or a product of one or more variables raised to counting number powers. So you can see right here that this is a monomial, mono meaning one, and we're going to get to polynomials shortly, and you will be able to see those. A polynomial is when we have monomials with addition or subtraction in between. We write those polynomials in descending order. You can see that it starts out with 5x cubed minus 2x squared and so on. X cubed, the 3 is the exponent, is the highest. Therefore, we will write that at the farthest left position and go to the right going down. The degree of a term in one variable is the exponent. So 7x to the 4th is or has a degree of 4. The degree of a polynomial has the highest degree of any non-zero term. So when we talk about the degree of the whole polynomial, you'll look for the largest exponent, and that is the degree. So 4x to the 5th means that this polynomial has degree 5. We use words such as linear, quadratic, cubic, polynomial, degree, one variable, or two variable to describe polynomials. So let's try a few of these. Number 1, how could we describe negative 3x squared plus 8x minus 4? Well, when we see that x squared, we know that any exponent any exponent that is equal to 2 is quadratic. So we can describe this as quadratic, we can describe it as one variable, and we can describe the degree as 2. Let's skip down to number 3. Number 3 has 6a to the 5th b squared in the first term. In order for us to know the degree of this polynomial, we will need to add the two exponents, 5 and 2. So this polynomial in number 3 is degree 7. So these slides, which will become available to you as part of this video, you can take notes on other words that were used to describe these. And you can see the last example that we just talked about has degree 7. So the important part of simplifying our answer is knowing how to combine like terms. When we combine like terms, we are looking to make sure that both the base and the exponent are identical. So we look at the coefficients first. Negative 7x cubed, the coefficient is negative 7. The leading coefficient is always the number in front of the variable with the largest exponent. So 3x squared plus 3x cubed plus 6x squared minus 4x minus 9. The leading coefficient of the polynomial is the 3 because it's the coefficient of the term with the highest degree. Looking at the last bullet item, the terms 6x to the 5th and 8x squared are unlike because x to the 5th is not identical to x squared. To combine terms, make sure you just add the coefficients or subtract the coefficients, whichever is appropriate, as long as the base and the exponents are identical. So looking at this example, 5x cubed minus 4x squared plus 2x cubed minus x squared, you are looking for x cubes and x squareds. When you sort those, you will then take the coefficients and add them or subtract them. So we have 5x cubed and a 2x cubed. So we add the 5 and the 2 to make sure we have 7x cubes. We have a negative 4x squared and a negative 1x squared. Even though there is not a visible 1 in front of the x squared, it is implied. So we have a negative 4 and a negative 1, or a negative 5x squareds. So when we combine terms that have more than one variable, we have to make sure that both the variable and the exponents are identical. So in the first term, 3p cubed times t squared, you'll only add or subtract the coefficients of others that have exactly p cubed or t squared. When you do that, your end result here is a negative 5p cubed t squared plus 8p squared t. When we're adding polynomials, we add like terms. When we're adding polynomials that have parentheses like this, when you're doing addition, it's really key. When you're doing addition, you can just remove the parentheses and start combining like terms. However, if you're doing subtraction, you need to make sure to distribute that subtraction throughout the second set of parentheses entirely. You can think of it as multiplying by a negative 1. When you multiply by a negative 1, you can see that what happens is you change the sign of everything inside the parentheses. So what was positive 6x squared becomes negative 6x squared. Negative 1 times a negative 4 becomes a positive 4x, and a negative 1 times a positive 1 becomes a negative 1. Combine like terms to get the final answer of x squared plus 2x plus 4. Now, you can do some subtraction and take a look at things in your graphing calculator. I'll let you look at that in your book. So just remember, one of the important things about subtracting polynomials is to distribute that negative 1 throughout everything inside the parentheses to the right of it. Good time to take a quick stretch break and get situated, because next up are functions. How many of you remember that a quadratic function has a graph that's called a parabola? The parabola is a smiley face or a frown-shaped graph, which if it's smiling, it has a vertex at the minimum of the graph or the bottom, and if it is frowning, it has a vertex at the maximum. And each one of these graphs, if you were to draw a vertical line through the vertex, creates an axis of symmetry. The axis or line of symmetry is similar to when you were young and would take a piece of construction paper to make a Valentine. You would fold it in half and cut only half the heart out so that you would have a perfect heart when you open that. That's the exact same thing about these graphs. That line of symmetry cuts the graph in half identically. So whatever point is on the right of the graph is equal distance from the axis of symmetry on the left side. So we can use these parabolas to find the answers to functions. So we're asked to evaluate the function at 4. Remember that when 4 is inside the parentheses, it's the same as saying x is equal to 4. Look at the blue lines on this graph. You go over to x equals 4, go up until you touch the graph, and however high up you went, that's the y value. And you can follow that blue line to the left to find out that you met at the point 4, 3. Now, this notation where you have the function of x is equal to a negative 3, remember, x is not equal to negative 3 necessarily. It is saying to find the function when y is equal to a negative 3. So look at your y-axis. Go down to a negative 3. You'll see the red lines in this picture. The red lines go to the left and to the right, and it finds points on the graph on both sides. On the right-hand side, you have 6, negative 3, and on the left-hand side, you have negative 2, negative 3. So this parabola has 2 x values when y is equal to a negative 3. Find x when the function of x is equal to 5. Now we're looking at the green lines on the graph. Again, f of x is equal to 5 is the same as saying y is equal to 5. So we go up to y equals 5 and come across until we hit the parabola. When we touch the parabola, we find the x value, which was 2. 2, 5 just happens to be the vertex. It is the highest point of this parabola. So that's important to know that the line of symmetry will go through that point. Now find f of x when it is equal to 6. If you go up the y-axis to 6, you'll notice that there's no points on the graph that will touch the parabola. They are non-existent. So there are times when you can say that it is undefined or non-existent for a value to be a part of the function. We have cubic functions, and cubic functions are in the form ax cubed plus bx squared plus cx plus d. And their graph is a little funky. It's a little curve that goes through 0 sometimes, and it has a upper bound of infinity and a lower bound of infinity. And you can see this is a graph for x cubed, and if you plot all of those points, it would look like the graph on the right. Now, we can add functions and we can subtract functions. If we were given the function 5x squared minus x plus 3 and another function negative 2x squared minus 9x minus 7 and asked to find the sum, we would add them. Remember that when we're adding, we can disregard the parentheses and just start to combine like terms. The function simplifies down to 3x squared plus 8x minus 4. It next asks us to evaluate the new sum function at 2. 2 is inside the parentheses, which means every place that there was an x, replace it with a 2 and evaluate that. You will end up with the answer of 24. You can use the same two functions but subtract them. Now it is important to notice that we have the negative 1 in front of the parentheses to the right, so we must change every sign of every term inside the parentheses. Negative 2 becomes positive 2, positive 9 becomes negative 9, and negative 7 becomes positive 7. Combine like terms, and you end up with 7x squared minus 10x plus 10. Evaluate that at 2. Plugging 2 in for every x, you find that it is equal to 18. Now, modeling with sum functions and different functions. This is done when we want to decide if the sum of a function a plus b represents two quantities. It will tell us the combined amount. And if we're looking at the difference of a minus b, it's telling us which quantity there was more of. So let's take a look at an example. We're going to look at women's and men's enrollments in U.S. colleges and universities. They'll be shown on the next slide in a table format. Keep in mind that enrollments are in millions. W means women, M means men, and they're modeled by the two equations that you see here. T will represent time, meaning years since 2010. Looking generally at this table on data, you can see that what's happening is the enrollment in millions for women and men are both decreasing, although right now more women are enrolled in college than men. Now let's see what happens when we add the functions and we evaluate them, or we subtract the functions and evaluate them. Both number 3 and number 5 are asking them to evaluate them when t is equal to 11, or 11 years since 2010. If we're going to add the two functions, remember we can disregard the parentheses, combine like terms, and we find our new function. When we want to evaluate that, we also have to think about what the terms were or the units were for each individual equation. The women's were in millions of women students, and men's were in millions of men students. So the combined function is now just millions of students. When we plug 11 in for x, we find that the total is going to be about 17.56. What this means is the enrollment will be 17.6 million students in the year 2021 according to this model. If we look at the difference, we have the negative 1 outside the parentheses, so we distribute and change every sign inside the parentheses. When we combine like terms, we end up with a negative 0.12 t squared plus 3.04. That is the equation to represent the difference between enrollment of women and enrollment of men. So we plug in 11 for the time, and we find out that it's 1.72. Because this is a positive number, it means the first equation was larger, so we know that there will be 1.72 million more female students than male students according to our model. I hope this helps you work on your 6.1 homework, and I continue to pray for you and your families, for your safety, for your good health, both physically and mentally, and that you can keep focused and working hard in class. I truly appreciate all of you, and have a good night.